All right, so we're going to talk about elementary reactions, and what that simply means is a single step reaction. So particles collide and they react. So if you do have a single step reaction, you can write the rate law really easily just using the coefficients in the balanced equation. So for example, A plus B yields 2C would be R equals K times A to the first times B to the first, because the coefficients are 1 and 1. Right? So these coefficients give us these exponents and they would just be 1. For multi-step reactions, you have to know that it's a multi-step reaction, and you can either be told that or you can have some knowledge that the rate law doesn't match the coefficients in the balanced equation. So for example, if I have this reaction, NO2 plus CO yields NO plus CO2, and the coefficients are 1, but my rate law is, maybe NO2 is squared, or maybe CO is not included, or anything that is, anything other than just a NO2 to the first power, CO to the first power, tells me it's probably a multi-step reaction. So if you're given these two steps, for example, NO2 plus NO2 yields NO3 plus NO, and we'll talk about speed of each step a little later, but and then NO3 plus CO yields NO2 plus CO2. It happens in these two steps. Each of these we could write the rate law for, and we'll do that in a minute. So the rate is going to be determined by the slower step. So the slower step is what we want to affect if we want to speed up the reaction or slow it down. In this case, the slower step involves only 2 molecules of NO2. And so our rate law for this overall reaction, even though there's no coefficient in front of NO2 in the overall reaction, and there's also some carbon monoxide in the overall reaction, our rate law for this overall reaction is just R equals K times NO2 to the second power. And so increasing the concentration of NO2 is going to speed this reaction up, but adding CO isn't going to do anything. Okay, so let's take a look at an example here. A reaction occurs according to the proposed 3-step mechanism below. So you can see those 3 steps right here. We're not going to worry about fast and slow for now. And it doesn't give us the overall. Write the rate law for each elementary step. So just treat each one like its own reaction, and since the elementary steps are by definition single steps, so we should be able to get the rate laws from the coefficients. So go ahead and pause and see if you can come up with those 3 rate laws. Okay, so hopefully for the first one you got R equals K times A squared, because there are 2 moles of A, or 2 molecules of A in that step. For the second one, R equals K times C times B, just raised to the first power because that's what's in that step. And then step 3 should be pretty much the same thing, only with R equals K times D times B. So those are our 3 rate laws. Okay, so we answered that question. The next step says, what is the overall chemical equation for the reaction? And so to get the overall equation, what we have to look at is what's on both sides of each arrow. And so the overall equation, after we put these 3 steps together, is just going to be an expression of what's actually changing. And so if we look, for example, at the fact that there are some things that are produced but then later consumed, we call those intermediates. Those will actually cancel. So for example, if we look at C up here, it is produced in the first step, but then consumed in the second step, which makes it an intermediate, and so I'm going to cancel it. The same thing is true of the D's. So there is a D produced in the second step and then consumed in the third step. By the way, if there had been something that was introduced, let's say in the second step, like B, and then later produced or kicked back out by the third step, that would be the opposite of an intermediate. It would still cancel, but it would be referred to as a catalyst. So we've talked a little bit about catalysts, But catalysts are just the opposite. They get put into the reaction, but then they also get produced or released in the same amount in the end. But either way, C and D definitely cancel. And then we also want to add up the things that we have more than one of. So we have 2 of A on the reactant side. We have 2 of B. We have 2 of F on the product side. And then we also have a mole of E on the product side. So if we just put those together, we should get this equation. 2A plus 2B yields E plus 2F. And then the next question is, it's unlikely that this overall reaction occurs in a single elementary step. Explain why. And so conceptually, all we're trying to say here is, okay, if I look at this reaction, if I just saw this overall reaction on paper, would you expect this reaction to be likely to occur as a single step? And the answer should be no, right? It is unlikely. It's possible, but it's unlikely. And the reason for that is because that would require all 4 particles to collide simultaneously. 2 of A and 2 of B have to collide in the same, be in the same place at the same time for this to happen in one step. It's much more plausible that 2 A's could collide to form C, and then that could collide with some of B to form D and F, and then and so forth. So the overall equation is not necessarily telling us something that's happening in one step. All right, go ahead and take a look at this one, give it a try on your own. We'll talk about it later in class. A 2-step reaction mechanism is proposed for a reaction as presented below. You see the 2 steps. So figure out A, the rate law for elementary step 1. Identify the intermediate and justify your choice. So again, you might have to rewind back and listen to the stuff about intermediates again. And then what's the overall equation? So do those things and bring them to class next time.